Okay, this is the Unit 2 Quiz 2 review, so let's go ahead and get started. All right, this very first question here we have seen several times this semester, so we're just going to go ahead and dive into it. If you remember, the very first thing that you need to do is whenever you're looking and determining whether or not it's arithmetic, geometric, quadratic, or cubic, the first thing you got to do is remember the geometric, that is the oddball. That's the one where it's kind of difficult to see. So the best thing to do is remember, I always look at the first two numbers and I just go, okay, is there anything I can multiply to 9 to get to 28? And the answer is no, or not a whole number, that is. So I already know that geometric's not going to be it. All right, so now I just start finding my differences. So that's 19, that's 29, that's 39, that's 49, and 49, sorry. And then obviously nothing so far, and then we'll go, 10, 10, 10. Oh, okay, well, all those 10s are the same. I went down two levels. That's going to be quadratic. What is the next number? Remember, add the final numbers at the end, and you get 204. Okay? All right, same thing. Is it geometric? I don't know. I just look at the first two. Is there anything I can multiply to 78 to get to 97? And the answer is no. So that automatically eliminates geometric. All right. So I just start finding my differences. And so when I find my differences, 19, 19, 19. Hey, look at that. They're all 19. So that means, well, I'm sorry, I only went down one level, so that's arithmetic. And then I just add these, I get 173. Write a recursive rule. Remember, recursive rule is a(n minus 1 something, even for number 4. Even before I even started, I know it's going to be a(n minus 1 something. And the something is, what am I doing every single time? So I'm at negative 28, I'm at negative 19, I'm at this. Well, I'm adding 9 every single time. There we go. All right. Here, let's see, I'm at 2, now I'm at 12. Well, you could say I'm adding 10, but then if you notice 12 to 72, I'm not adding 10 anymore. So I'm multiplying by 6. There we go. Find the missing term in the arithmetic sequence. Remember, in order to find the missing term, it is to find your common difference. The first rule is take the later and then subtract it from the earlier. And then we're going to get a number, and then we're going to divide that number by the number of jumps. All right. So this is the later term. This is the earlier term. Okay. So that's going to be 17 minus 25, and I'm going to get negative 8. All right. And I'm going to divide that by, let's see, 1, 2, 3, and 4, divided by 4 jumps. So that means my common difference is negative 2. So that means I'm subtracting 2 every single time. All right. So when I fill in the missing pieces, I'm just going to subtract 2 every time. So 25, 23, 21, 19, and then 17. Now, like the last review, I'm just going to give you the first one, and I'm going to show the first one, and then I'm going to just go ahead and give you the answers for question number 6. I mean, technically, when you're working through this review, you're not you shouldn't be copying. Okay, you shouldn't be blindly copying. You should be pausing the review, working, and then playing the review again just to check your work. All right, for the geometric sequence, remember that is your r. So in order to find your r, the very first thing I need to do is take the later term and now divide it by the earlier term. And I'm going to get a number, and then I'm going to root based on the number of jumps. Kind of hard for me to write that in notation here. So negative 16 is the later, this is the earlier. So negative 16 divided by negative 1, which gives me positive 16. And then, let's see, 1 jump, 2 jump, 3 jump, 4. That's 4 jumps. So I'm going to take the fourth root of 16, which ends up being 2. So r equals 2. That means I am multiplying every single time by 2. So negative 1, negative 2, negative 4, negative 8, and then negative 16. All right. The next one, it looks like my r is going to equal 3. All right, so that means it's going to be 6, 18, 54, and then 162, I imagine. Yes. All right, moving on. All right, given the recursive formula for the arithmetic sequence, find the first 5 terms. So 1, 2, 3, 4, 5. Now remember, the recursive rule tells you what you're doing every single time. I'm subtracting 30. My first term tells me where I'm starting. So negative 35, and I'm going to subtract 30 every single time. 65, negative 95, negative 125, negative 155. That's what I'm doing. for 10, I'm starting with 28, 36, let's see, 44, 52, and then 60. There we go. All right. Given the explicit formula for the arithmetic sequence, find the first 5 terms. All right. Now, typically, again, I've said this several times in class, that it would be written with the n term first, but this worksheet generator just always likes to put n second. 1, 2, 3, 4, 5. So remember, guys, 2 as well as 10 is not the first term. So please don't do like 2 and then start working. That's incorrect. All right, remember, in order to find the first term, you have to take the little 1, plug it into n. So that's like 2 minus 10 times 1, and you get -8. To find the second term, take the little 2 and plug it in for n. So that is 2 minus, I went ahead and multiplied it, but 10 times 2, which gives you -18. The little 3, plug it in. Now, you shouldn't have to necessarily do this every single time where you're plugging numbers in, because you should kind of get a pattern. If you notice, I'm at -8, -18, -28. You know I'm subtracting by 10 at this point, so that's -38. And then lastly, this will be -48. All right. So hopefully you're getting the overall concept here. So this first one, again, I'm just giving you the answers, because I don't want this video to be forever and a day long. Um, plus I want you to work it as well. All right, next one. All right, now the most common mistake, and that is when you're given the first term and the common difference, is what someone does. They simply just do, oh, okay, that's going to be easy. 3n plus 36. Guys, it's never that easy. You know that. It's never that easy. So if you remember, you have to use the arithmetic formula here. And the arithmetic formula is a of n is equal to something plus something n minus 1. My first term is 3. I'm sorry, my common difference is 3. My first term is 36. Take this, that's 36, plus 3n minus 3. Combine the first, combine the last, and you get 3n plus 33. And let me just spend a second. Guys, you can easily check your work. You know that your first term is 1. So take little 1, plug it in for n. Does the whole thing equal 36? And if the answer is yes, then you're correct. Okay? So I'm going to camp on this for 1 second. Let's say if you were someone who made the common mistake of just doing this, 3n plus 36. Let's say you did that. Well, again, check your work. If you were to plug the little 1 into n, then the whole thing should equal 36. And guys, I'll go and tell you, you plug in 1 for n, you're going to get 39. That does not equal 36. So obviously, you know this is all wrong. So do not get lazy. Okay, do not get lazy and just plug the answers in because you think that's what you're doing with arithmetic. All right. Question number 17. Let's see. Question number 17. Let's see. Pause for the video. Oh, I thought I had the answers already. I didn't. All right. So let's see. It will be 17 minus 9 times n minus 1. Distribute. That becomes 17 minus 9n plus 9. Combine the first, combine the last. -9n plus 26. There we go. All right, find the explicit formula. Your equation should. All right, so again, same concept, guys. Do not just go, oh, okay, well, there's 26, and I am subtracting 8 every single time. So that's 26 or -8n plus 26. It's never that easy, guys. So, so again, a of n is equal to my first term plus my common difference, n minus 1. My first term is 26 because I can literally see it right there. And I'm subtracting 8 every single time. -8, -8, getting distributed. 26 minus 8n plus 8. Combine the first, combine the last. -8n plus 34. Okay? All right. So again, I don't have the answers here. I'm just going to go ahead and just solve it real quick without really using much talking or anything. Subtracting 10, 36 minus 10 and plus 10. Combine the first, combine the last, negative 10n plus 46. There we go. All right, so now we get into some word problems, and we got to make sure that we understand what exactly we're doing and what's being said. So it says he already has 5,200, so that's my first term. So my first term, A of 1, is 5,200, and then he'll continue to save 400 each month, so that's my common difference. So in this case, everything worked out for us because we were given the information we need in order to do this. So my common difference is 400, this is 5,200, distribute, so that's 5,200 plus 400 in minus 400. Combine the first, combine the last, 400 in minus 400. Ooh, messed up. Hold on. Let's try this one more time. 400 in plus 4,800, sorry. There we go. All right, so John's dad set up for question number 20. After 10 hours, A of 10, he earned 820 bucks. After 20 hours, A of 20, he earned 1620. All right, so this question is going to be a little more challenging because I got to find my common difference D, and I also got to find my first term. So I got to do pretty much everything for this one. So my common difference is, remember, this is the later term, this is the earlier term. So 1620 minus 820, I believe, is 800. And I'm going to divide it by, let's see, that's A of 10, that's A of 20, divide that by 10. So my common difference is 80. All right, so now I need to find my first term. So A of n is equal to something plus something. And we have done this so many times, guys. Y'all should know exactly what I'm doing even before I do it. So my common difference is 80. I'm looking for my first term. I'm just going to choose this information because it's the smallest of the two. I'm going to take 10, plug it right there. So 820 is equal to x plus 80 times 10 minus 1. All right, and I'm just going to use algebra to solve. 820 is equal to x plus, this ends up being 720. All right, so my first term ends up being 100. All right, so now that my first term ends up being 100, I got to clean I'm going to clean all this up here. So my first term ends up being 100, I believe. Yes, I'm going to go with that. All right, so now for my final answer, A of n is equal to something plus something n minus 1. I know that my common term is 80, or my common difference, and then my first term is 100. Distribute, and that gives me 80 n minus 80, sorry, 100 plus 80. Combine the first, combine the last. I'm at 80 n plus 20. There we go. Now, just for checking, okay, I'm going to choose this, all right? If I plug in 20 here, I should get 1620 there. So that means, and this is just checking my work, because remember, there's no reason why you should be guessing on this. All right, that ends up being 1620. That is a match, so yes, this is my answer. All right, so questions number 21 and 22 are literally the exact same as question number 20. Okay, so rather than going through the same process every single time, I'm just going to go ahead and give you the answers just to keep this video from being insanely long. All right, so the answer for this one is going to be negative 5n plus 18. Now, if you're watching me, do not just write down the answer. You need to actually solve the answer or solve the question so you know exactly what you're doing. This ends up being 2n plus 17. All right. All right, now we're in geometric sequence. All right, now remember, geometric is, if you look at my example, this is my first term. This is what I'm multiplying by. All right, so if I was to create a sequence, it's A of n, and technically you don't really need the A of n. I just do that just for thoroughness in some case. So my first term, literally, right there, I can see it, eyeball test. Boom, there it is. The next thing is, what am I doing every single time? So I'm at negative 3, I'm at negative 9, I'm at negative 27. I'm multiplying by positive 3, so that means I'm just going to put 3 there. That's it. And I'm done. The next question here, a of n is equal to something, parenthesis something, n minus 1. Again, what's my first term? I can see it. It's 2. What am I multiplying by? 6 every single time. All right. So it says, given the explicit formula, find the first 5 terms. So very similar to the um, the arithmetic sequence. Now, the thing is, if you know anything about geometric, you know that this is the first term. All right, it's 3 because literally the way geometric works, the first number is the first term. The second number is what you're doing every single time. And that's, okay, I'm multiplying by 2. So that's 6, 12, 24, and then 48. All right. Now, just in case you might have forgotten that, if you would have forgotten that, I've said this before in class, and that is, let's say you forget how the geometric sequence is set up. You know you're looking for your first term, so you can always plug a little 1 into n to figure it out. So 3 times 2 to the 1 minus 1 power, when you do the math, it ends up being 3. So either way, you're going to figure it out, either by just knowing what the formula is or just plugging the information in. So I'm looking for the 2, and that would be 3 times 2 to the 2 minus 1 power, and that ends up being 6. And then, of course, if you want to do it one more time, 3, plug it in for n. So 3 times 2 to the 3 minus 1 power, which then gives you 12. So at this point, you should already know what you're doing. Oh, I'm multiplying by 2 every single time, 24 and then 48. All right. For this one right here, the answer is -2, -10, -50, -250, and I believe that's all we needed to go for. Yes. Oh, first 5 terms. Okay. -1250. There we go. Okay. So question number 27, very simple. I'm giving you my formula, and I'm saying, hey, find the 9th term. Literally take 9, plug it in for n, and it becomes like -2 times 5 to the 9 minus 1 power. Of course, you would never raise it to the 9 minus 1 power. You would raise it to the 8th power because sometimes your calculators might do weird things. So go ahead and mentally solve everything if you can before plugging into your calculator. There's your answer. And remember, since it's geometric, you are going to be dealing with a lot bigger numbers because you're multiplying as opposed to adding. There's your answer, 28. Okay, now 29 and 30, now we start getting into a little more challenging stuff because if you notice, we got to create a formula. We have our 5th term, but we do not have our first term. So we're going to use, just like arithmetic, we're going to use the geometric formula to work backwards to find our first term. Finding our first term, we don't know it, but we do know r is 5, and we're going to take 1875, plug it there, and little 5, and plug it right there. So that's 1875 is equal to x parenthesis 5 to the 5 minus 1 power. Now, I'm not going to actually put in my calculator 5 minus 1. I'm just going to do 4. So that would be 1875 is equal to, I think 5 to the 4th power is 625, and it is. So that ends up being 625x divided by 625. X is equal to 3. So that's my first term. So my first term is 3. So my final answer is a of n is equal to something, parenthesis something, to the n minus 1 power. My first term was 3. My r was 5. Boom, that's my answer. What's great about this formula is that you do not have to simplify it. Once you plug it in there, you're good. All right, so question number 30, the answer is +3 to -2 to the n minus 1 power. Okay. Moving on. All right, question number 31. All right, so question number 31 is kind of a tricky question, but it's not really, because the reason I call it tricky is because students are like, oh, I got to find what my R is, and then I got to find my first term. Literally, first term's already given to you. All right, that's what throws students off. So all I got to do is find my R. Now, if you remember, finding your R is the later term divided by the earlier term. Whatever number you get, that's what you're going to root. Okay. Now, this worksheet is just, it's set up weird to where the later term is actually to the left in this one. So this is my later term, this is my earlier term. So That's going to be 12,500 divided by -4. And I get -3, 1, 2, 30, yeah, 3,125. But then that's my sixth root. That's my, oh, I'm sorry, that's my sixth term. That's my first term. So I'm going to fifth root it. So 5, I bet you that's going to be -5. Let's see. And I messed up. There we go. Yep. So my R ends up being -5. So my R ends up being -5. So my final answer is going to be A of n is equal to my first term, which is -4, times my R, which is -5, n minus 1. There we go. Now, question number 32, I'm actually going to do because it's actually something that we haven't seen where we're given two different terms. But finding R, there is a little trick on finding R. Some of you guys might remember from the week. If you notice, we got to find R. So obviously, we got to, again, take the later term divided by the earlier term. We're going to get a number. All right, but this one's special, and let me go ahead and divide. So 128 divided by -132, I believe that ends up being -4. However, the number of roots, notice how that's the third term, that's the fourth term. It's only one between them. So if there's ever one between, you do not do anything else. The answer is -4. That's your R. All right, so your R is actually -4 in this case. R is actually -4. So now we got to find our first term. So finding our first term, we're going to choose, I'm just going to choose this guy, okay? So remember, our formula is A of n is equal to something, parentheses something, to the n minus 1 power. I know that my R is -4. I'm going to take 32, plug it there, -32, take 3, plug it right there. So that we're going to find my first term. So -32 is equal to x parenthesis to the -4 to the 3 minus 1 power. -32 is equal to, it ends up being positive 16x, okay? X ends up being -2, okay? So that's my first term. So my final answer is going to be A of n is equal to something, parentheses something, n minus 1. My first term is -2. My R is -4. I'm done. Okay. Now, again, if you ever want to check your work, I'm just going to check right here. Plug 4 into n. Does it give you 128? And the answer is yes, then you're good. All right. A software engineer is working on an algorithm for the company's website. The algorithm uses a geometric combination. All right. So it says A of 7 is 8,019. And then A of 10 is 216,513. So you're literally doing the same exact thing. Okay. So, and let's see. And question number 34. Nina and Zoe are selling Girl Scout cookies. They sold 2 boxes on Monday. So the problem starts with Monday. So that's A of 1 is equal to 2. And this is 8 boxes on Tuesday. So it's like A of 2 is equal to 8. And then A of 3 is equal to 32. All right. So I'm gonna jump to 34 and I'll jump back to 33. So question number 34, again, you know you're doing the arithmetic sequence. Your first term is given, and that's 2. Now this one here, it's just kind of stretching your brain a little bit. What is your R? Well, if you notice your first term, your second term, your third term, you're multiplying by 4 every single time. All right, so I'm just trying to get you to kind of see the situation without having to dive all the way into all the calculations. Here you can just use your eyes and go like, oh, I'm just multiplying by 4. That's my R. All right, for this one right here, for going back to 33, again, you got to find your R. All right, so 216,513 divided by 819. So 216,513 divided by 8019 is equal to 27. That's my 7th term. That's my 10th term. Sorry, my computer is slowing up a little bit. That ends up being positive 3. So A of n is equal to something, something, n minus 1. That we're running into a repeater here, guys. That's 3. I'm just going to take 8,000, put it there. I'm going to put 7, put it right there. So 8,019 is equal to x parenthesis 3 to the 7 minus 1 power. And so, let's see, 3 to the 6 power, because, so it becomes 729x is equal to 8019. So 8019 divided by 729. All right, so my first term ends up being 11. So my final answer is going to be A of n is equal to 11 parenthesis 3 to the n minus 1 power. All right. Toby bought a car for $60,000. The average depreciation rate is, I think this is it. Oh, this is it. Create a formula. All right, so depreciation means you're going down. Now, if you remember, guys, if you're ever going down, that means you're going to take the percentage and subtract it from 100%, and that would give you 78%, which we will convert to 0.78. That's going to be your R, okay? And my first term is what the car started off with being, so 60,000, parenthesis, 0.78, n minus 1. Super easy. The only concept that we're working on right now is making sure you know how to convert your percentages. So Susie put 2,000 in the bank. That's what the problem started with. That's your A of 1. And it says that that the bank pays, which means you're increasing by 2%. So if you remember from the previous day, if you're ever increasing by 2%, you're going to add it to 100 and then convert to 1.02. So it's going to be 2,000, parenthesis 1.02 to the n minus 1 power. There you go. So that's it. Thanks for hanging with me. Let me know if you have any questions. Thank you.